Alright, in this video we're going to look at converting from rectangular or xy coordinates to polar coordinates. So again, going back to our XYR right triangle, this time we're going to know what the value of x and the value of y are going to be, and we're going to use that information to find the polar representation of that point. So again, keeping in mind from some of the things we talked about in the past that the value of r is going to be the square root of x squared plus y squared, so Pythagorean theorem, and theta prime is the inverse tangent of the absolute value of y over x. So theta prime is the reference angle that is used to find the total amount that we rotated theta. So what we're going to do is we're going to plot the point, the x and y coordinate. We're going to just plot it. Doesn't have to be perfect. We just want to know what quadrant we're in, essentially. And then we'll find the reference angle using this relationship. And the absolute values are just to make sure that we're guaranteed an angle between, an acute angle between 0 and 90. And then from there, based on what quadrant we're in and what we got for this result, we can figure out the total amount we rotated. So let's take a look at example 3. We're going to convert the point -1 square root of 3 into polar coordinates. So our point would be somewhere in the second quadrant, so maybe about here for an x is -1 and y is the square root of 3. So first thing we can do is we can find the value of our, and here's our triangle in the coordinate plane, but finding the value of r, we get r is the square root of 1 squared plus the square root of 3 squared. So again, in order to avoid any issues with forgetting to put negative numbers in parentheses, I advise you to just ignore them altogether. So 1 squared plus the square root of 3 squared is 4, so taking the square root of 4, we get a radius of 2. So now we want to be able to figure out what this angle measure is, and in order to get that angle measurement, we're going to take the inverse tangent of this square root of 3 divided by this -1, but we want the absolute value, so we're going to get back an angle between 0 and 90 in return. So when we do that, the inverse tangent of square root of 3 over -1 is negative square root of 3. The inverse tangent of positive square root of 3, because again the absolute values, we just drop the negative signs, but the inverse tangent of the square root of 3 is 60 degrees. So this angle here, this radius, this hypotenuse here, makes a 60-degree angle with the negative x-axis, which means we want to figure out, starting from 0, how many total degrees we rotated to get there. And from this one, we would have gone 180 degrees to get to the negative x-axis, but we stopped 60 degrees short. So that means our terminal side, our radius here, rotated a total of 120 degrees. 180 minus the 60 degrees we have to backtrack. So we have 120 degrees. So our polar representation of this point is 2, 120 degrees. Now, before I go on to the next example, I do want to note that unlike x and y coordinates, polar coordinates, there's actually an infinite number of ways you can represent them. So, for instance, in the x and y coordinate plane, this point has only one representation, an x coordinate of -1 and a y coordinate of the square root of 3. However, in polar coordinates, one representation is at 2 and 120 degrees. However, another representation is, instead of going to the right 2, we go to the left 2 and then rotate 60 degrees clockwise. So this would also have polar coordinates of -2, -60 degrees. And again, I'm not referring to an infinite number of ways because of the converting the 120 degrees to 2 pi over 3 radians, but we could also have gone out to rotated 360 plus another 120 and gotten 480 degrees. So 2 and 480 degrees is another valid representation of this point. And because of coterminal angles and rotating around the coordinate plane, polar coordinates have an infinite number of ways to represent them. So in order to prevent that from becoming an issue, I'm going to ask that for polar coordinates, you give me an r value that is positive and an angle between 0 and 360 or 0 and 2 pi. So unless you're told otherwise, I'm going to ask you to give me a positive value for r and an angle that's between 0 and 360 or 0 and 2 pi. All right, part B, the point 1, negative 1, so over 1, down 1. So if we connect those, we x value of 1, y value of negative 1, and using our Pythagorean theorem, 1 squared and 1 squared is square root of 2. So we have an r value of the square root of 2. To calculate this theta prime, this reference angle, we're going to take the absolute value of negative 1 divided by 1, and then take the inverse tangent of that. So this will be the inverse tangent of 1, which is 45 degrees. So this makes a 45-degree angle, which means we would have rotated 315 degrees to get to that point. So 45 degrees, and we rotate 315 degrees to get this terminal side. Again, you could have taken 360 degrees, but we stopped 45 degrees short. So 360 minus 45 is 315. So we have an r value of square root of 2 and an angle of rotation of 315 degrees. All right, that about does it for this video. In the next video, we'll take a look at converting polar and rectangular equations, so entire sets of points at one time. So I'll see you then.